Introduction to Data Structures by Mrs. Snehalatha, Assistant Professor, Department of CSE.
Subject name is Data Structures and Applications. The subject code is 18CS32. So this is what you will be studying in this entire course. Introduction to Data Structure, where you will be studying arrays and structures, then strings, then recursion, then stacks, queues, linked list, trees, sorting and searching, graphs, hashing, and files. Okay. So I think most of the keywords I think you have come across in your previous semesters when you were studying that is C language. So like stack, recursion, probably not in depth, but at least you know those keywords. Okay. So when you study this subject, like what will be the outcome of learning this subject? So which we try to measure in terms of course outcomes. So as you know that since we follow outcome-based education, so every course we need to define what is called as course outcomes. This is basically like we try to measure how much the student has learned after studying this subject quantitatively and as well as qualitatively. So with respect to levels, which we call it as Bloom's level. Okay. So as you know, there are 5 levels. So L1, L2, L3, L4, L5. So starting from understanding, then remembering, then apply, analysis, and design. So total we have 5 levels: L1, L2, L3, L4, L5. So in this course, we have defined 4 COs. Okay, so which you can see, which has been shared in the screen. So the first CO is utilize the fundamental concepts of data structures and their applications for problem solving. So you will understand, so like when you learn this subject, probably you will understand the basic fundamental concepts of why to study the data structures and its applications in real time solving the problem. So, and it is at L3 level. So L3 is at apply level. Okay. And the next CO is, the second CO is choose appropriate linear data structures to solve given problem. So your entire data structure is being categorized into linear data structure and non-linear data structure, which you will learn like as you go ahead. So depending on a given problem, so when you try to solve a given problem, so it is not that you have n number of data structures. So which one is suitable for your problem, you have to choose. So choosing an appropriate data structure for solving a problem is the biggest challenge. Okay. So that is what the second CO says. Choose appropriate linear data structures to solve given problem. Then again, it is at L3 level, that is at the apply level. And the third CO is about make use of non-linear data structures for problem solving. So the second CO is about linear data structure. So you have a different linear data structures. So which one you are going to choose? That is about the second CO. And the third CO is on non-linear data structure. So again, level L3, and CO is about, so definitely the most common application which today real time we use is searching, sorting, and all. So, and you have different searching, sorting algorithms. I think few of them you have already studied in your I mean to say like problem solving subject, that is in your first sem. So few more complex searching and sorting algorithms you'll be studying in this semester also in this subject, along with some techniques which we call it as hashing techniques for processing the data, where searching becomes very simplified and it takes less time. So that concept we are going to study. So that's about the last CO. So applies sorting, searching, and hashing techniques for processing data. So again is at the level L3. So these are the 4 COs, and when we learn any of the topics in the subject, we try to map with any of the COs. It could be activity, or it could be assignment, or it could be your internal assessment. So anything we do, so probably we try to map with any of the COs, one or more COs, and the corresponding level we try to map. So that means L3 level. So here all the COs are at the L3 level because this is the fundamental subject. So probably we are at level L3. We are not gone for analysis part. So all the COs are at the level L3. Now coming to the course information, the prescribed textbook, what you have is, there are two textbooks, okay? So I mean to say the prescribed textbook. So one is Ellis, Horowitz and Sartar Sahni. So the title is Fundamentals of Data Structure in C, and it's the second edition. And the second textbook is Seymour Lipchun's Data Structure, that is Sham series. So that is published by McGraw-Hill. So these are the two prescribed textbooks. So if you go through the syllabus, like a few topics are from the first textbook and few are from the second textbook. So the topics is being divided among these two textbooks. And one more reference book you have is, that is Frozen. Okay, so that you can also refer. Now coming to why to study this subject. So what is the importance of this subject? Where we apply these concepts in our real-time problems. So what is all about this subject we talk about? So let us have a glimpse on it. So basically, hello? Hello? Can you hear me?
Yes, ma'am.
Okay, and is this screen visible?
Yes,
Hello?
ma'am.
Okay. Can any one of you tell me, like, what data is all about? So one of you can tell me, what is data all about? What do you mean by data? Because you hear the word data, data, data everywhere, even in your real time or even in your computer applications or when you use your mobile applications. So you talk about data. So what is all about data?
Data is information, ma'am.
Data is information. Okay. Anybody else? So how it is being represented? So when you say information, what are the different means of representing the information? Is anybody? What are the different ways of representing the data? Yes?
Binary.
Yeah, please speak out. No problem if it is wrong also. Whatever you know, you can tell. What is data? Yeah, you said data is information, fine. But how do you represent it? Suppose if I say your name, how do you write your name? Your name is made of alphabets. It's a text, is it not? Yeah, but in real time, when you talk about data, is it only the text part we see? Is it the text is the only data we deal with? What are the other ways?
Pie chart.
Ma'am, data is a collection of raw facts.
Collection of raw facts. Okay, fine. So how
information is something which has that proper meaning.
Okay, it has been processed. Okay, so yeah, that's the difference. Data is the raw facts. The processed data is called as the information. Okay, then anybody else?
The information can be either text or images and also audio clips.
Yes, very good. So information can be your text, it can be number, it can be image, it can be audio, it can be video. Today we talk about text is very less. Today we all deal with multimedia data. What do you mean by multimedia? What do you mean by multimedia? What is multimedia? You say multimedia application. What do you mean by multimedia applications?
Communication is expressed in more than one form.
No. Anybody else? What do you mean by multimedia?
And all sort of medias like photo, video, and text, binaries, and all that.
Okay. So generally, any applications that deals with audio and video data is called as multimedia application. Okay. So today, what we talk about, all YouTube and all, generally it is of what? Audio and video. So so any data that you deal with audio and video, so we call it as multimedia applications. Okay. So today, so your entire computer science is all about what handling data. Okay, so data can be in any of the form. It can be in text, it can be image, it can be audio, it can be video, it can be numbers. So what we learn in computer science subjects is all about how to store these data and how to process this data, or how do you compute from a given data. So that's all about what is computer science. Okay, and when I say storing the data, how do you store the data? So is it just randomly you store the data? Suppose I mean to say, like you go to a kitchen. Okay, so probably all of you have seen your kitchen at home. So how the things are placed? I think girls can answer this question better. Okay, what do you see when you go to kitchen? Hello? Hello? Hello, can you hear me? Hello?
Yes, ma'am.
Okay, yeah, I think girls are not interested to say. I think guys can say. Okay, what when you go enter into kitchen, what do you see first?
Food.
Huh?
Food refrigerator.
Hello?
We
Hello?
see the utensils arranged, ma'am.
Okay, you see the utensils arranged in a particular place.
Yes, ma'am.
Then the things like groceries items are neatly arranged. Okay, so is it not like, imagine if everything is not been sorted, what would have happened? Things would have been their place only. Then why it has to be kept in a proper place? Utensils in one place.
It will be
Then
distorted and we can't find at the time when we need them.
okay, it takes more time to search a particular thing. Okay, so that's the reason it is not just storing is important, how well it is being organized is very important. Okay, suppose you open your cupboard. Okay, so how your clothes are kept? Is it just you dump in and you want to come to college and you want to find a shirt? Imagine everything is being dumped in your cupboard and you want to wear one shirt and you are searching for it. What will happen? If it is not being sorted out, it is not being arranged in a proper manner, what will happen? What will happen?
We'll be late for college.
Okay, it takes too much. Sometimes you may not find also. So even if you find also, it takes too much of time. So it is not efficient. Okay. So storing data is not just very important. Okay. How well you organize your data, how neatly you arrange the data in a particular structure is very important in real life also. Okay. As well as in computer applications also. It's not just in real life, but also in computer applications, since you deal with lot of data, how this data is organized, how efficiently you are going to retrieve this data, and how effectively you are going to process this data is very important in solving a given problem, okay, or in real-time applications. So that's the reason we are going to deal with a subject or the concept what is called as data structure, okay. So why to study data structure is it helps you to deal with the different ways of arranging, processing, as well as storing the data. So when I say data, it is not just storing. It has to be neatly arranged. Then once you arrange the data in a particular order or a particular structure, it will be processed. That means you do some operation on those data and then storing the data. So this is what all about what we are going to study in data structures, how it is organized, how it is processed, and how it is stored. Okay, and all codes are made for real-time purpose. Okay, so generally, like when we deal with the data, so they are made for real-time purpose. So data structures allows the user to provide or to use or handle the data in a different ways. Now coming to as a programmer, because we are all computer science, I mean to say we belong to computer science. So day to day we deal with programs, okay, because our day ends with, our day begins with program and ends with program, because our job is only to do programming. So what basically programs are comprised of, okay? So one is data and the other one is very important is algorithms, okay? So these are the two things which is required to develop a program. Any language, no matter I write a program in C or C++ or Java, Python, R. So name any programming language. Languages just gives you the different syntax and structure. That's it. But the fundamental elements of any program is, one is it needs data and the other one is it needs algorithm. Okay. So what algorithm describes? So algorithm basically describes the way the data is to be transformed. Okay. You apply some algorithm for a particular data which will convert one form to another. Okay. Take for example, I want to arrange the elements in ascending order. Probably I'll give the input which is been shuffled. That means it is not arranged in any particular order. Then I will apply one algorithm. So probably like bubble sort or something like that. Then and after applying that algorithm to the input data, it will arrange it in the ascending order. So basically algorithm describes the way the data is to be transformed from one form to another. And the reason for learning why the data structure is because we need, it is not just we want some raw data. We have to give some structure to the data, and that makes the algorithm more simpler and easier and to maintain, and which is faster. Okay, so that's the reason organizing the data is very important, and to transform from one form to another, we apply the algorithm. That's the reason most of the times data structure and algorithm put together, we have one subject. Okay, but in your case, you will be studying data structure in the current semester and algorithms you are going to study in the next semester, because most of the times they go parallel. Okay, so that's the reason like these two are the very fundamental concepts for developing any program. One is we need to choose an appropriate data structure, and the second one is the algorithm which is going to transform this data. So that's the reason. So computer science is all about this data and algorithms. Now coming to, so just you can see this picture or whatever the image what you can see on the screen. So a lady is trying to take a book. So and she is like she's searching for some order, like she has gone for order section and she finds an algorithm book. And she's saying, who is putting all the algorithm books in the order section? So definitely this is what happens in a real life. If you go to a library, so if the books are not arranged in the proper section, suppose all mechanical subjects books are in one rack, all computer science books are in one rack, all civil books are in one rack. And if you go to a library and if you find a civil book in computer science section, you feel awkward. I mean, it's not awkward. I'm to say you get irritated because you find a data which you are not interested in. So that's the reason. So when we deal with the data has to be organized in an effectively manner so that it is retrieved efficiently and it is being processed efficiently. So that's all what is data structure is. Now coming to where we apply this data structure concepts in a real-time problem, how you can relate. Okay, so to solve some real-world complex problems, so what you can see is the first thing, as I told, how to find your book or clothes in your messed up room. Okay, so if you don't arrange them properly, one above the other. So you suppose if you want to keep a book, either you can pile them one above the other. Okay, if you don't have a space, or you can keep next to next. Okay, so even your clothes also in your cupboard, if you don't pile them properly, so then searching them becomes very difficult. So I think the data structure what you can use is stack. Stack is something which is arranged one above the other. Either you want to add or remove, always it is done from one end. Suppose if you go to a canteen, okay, or restaurant, probably canteen is the best. If you go for a meal there, probably you could see that a pile of, I mean to say, plates is being arranged, empty plates, what I mean to say. So whenever a person orders for a meal, the person, it takes out a plate from the top and he puts the things and he gives it to the, I mean to say, whoever the person who is asking for the meal. Then again, if you want to add a plate to that stack, you will add it from the top. So you will not remove from the middle, nor you remove from the bottom, because one end will be fixed. So you try to add an element or remove an element only from the top. So that is nothing but stack. So in canteen, what they use when they arrange the meal plates, it is nothing but the stack. Even in your cupboard, when you try to keep the clothes, you will keep one above the other. So that is nothing but the stack. So again, if you go to a library, okay, so if you need to find a book on set theory, okay, that is, it's a mathematical subject. So you go to the math section first, okay, where you find. So if the things are not being sorted properly, it is very difficult to find a particular data. Then very important thing is, so these data structures are also applied in your social applications, social networking applications, which is one such a very famous application is your Facebook. Probably everyone, you have an account in Facebook. So when you go to Facebook, what is that you see? Friends, the mutual friends and all. So what happens is probably you will have a common friend or friend of friend. So you will have mutual friends. Now, how does the Facebook will come to know? Probably it will guess that you are a mutual friend, because when a person creates an account in the Facebook and he makes a friendship, so it will try to represent the relationship between that person who has an account with the friends in terms of graph. Okay, so graph basically gives you the connectivity between the people. So generally in all your social networking, so this is how the relationship between the people are represented using graph. Graph is one such data structure, so which you will be studying. What should be the properties of the graphs, what it contains, how it is represented, what kind of data can be represented using graph. So Facebook definitely uses a graph data structure where every node is a people. So what you can call every node is a people, and the edge between the nodes represents the relationship between the two people. So who is connected to who is a friend of friend. Okay, so that relationship is represented using a graph. So definitely this is very one important good data structures which we can use when we have to show the relationship between the data which is being connected. So that is how you can use. Then also if you have a deck of cards, okay, so suppose you have a cards and you want to organize it. So just do you place it on a table, just throw it like this, or you will arrange one after the other? So you will pile it one above the other. That is nothing but the stack, and you try to remove from the top. Again, you have something called searching a word in the dictionary. Okay, so when you have a dictionary and you want to search the meaning of a particular word, so you go to a particular alphabet and you will search for it. Okay, there, so what you can see, searching a word in the dictionary, it is nothing to do with the data structure. Here, more or less, we are giving importance to what algorithm you use to search a given word in the dictionary. Either you will start searching from the first page, or you will go to the middle of the book, and then either you come backwards or you go forward. That is nothing but the binary search. I think one such that binary search algorithm, I think you have studied in your C language, where you have implemented program also. So using binary search, you try to reduce the time, and searching an element becomes faster. So here also, so in such applications, rather than preferring what data structure we use, we try to give importance to what algorithm we use to search a given word in dictionary. Then again, if you go for GPS, today I think all of you, when you go to a new place, what is that you first switch on? You switch on your, I mean to say, you switch on your Google Maps. Okay, so which is nothing but it makes use of the GPS navigation system. So it gives you the connectivity from one place to another and which path it has to use. So how it is being represented? So again, it is nothing but it uses the graph data structure. Okay, and again in the GPS navigation system, when you use graph, so probably you will have multiple paths. Suppose if I want to go from RR Nagar to Jayanagar, I may have n different paths. I can go via Uttarali, I can go via Mysore Road, I can go via Kanakpura Road. So I can have n different paths. So, but generally, which one we go for? We go for the shortest path. That's one very important application which we use in your GPS navigation system, because your Google Maps also go for shortest path. Okay, it always shows the path which has the shortest distance. Okay, so that's the reason. Again, you can see that graph is being used in several applications like your GPS navigation systems. Okay. Then you have Google Maps platform. Then suppose you are working in a company, then you would like to know the hierarchy of persons in a company. So who comes first, under which person who is working. So you will have a project manager. Under project manager, you will have a team leader. Under team leader, you will have a subordinates. So, so if you have an hierarchical relationship, so basically you have a different levels of, data, then the best data structures you can use is the tree. So you know how tree looks. It will have a node, it will have the sub nodes, and you will start traversing from the root node to the leaf of the node. So that is how tree is. So, so that's the reason. So what you can see into all these problems is they are not computer problems. They are real-time problems, okay? So we try to solve most of the real-time application problems using one or the other data structures, depending on the efficiency of that particular data structure. It's not that all data structures is suitable for all kinds of data. So one data structure may be suitable for with respect to memory efficiency, one with respect to time, one with respect to handling the data, one with respect to time. Depending on how you want to solve a given problem, you have to choose an appropriate data structures. So that's all. So we will, in this course, we will be looking into various data structures, what we have, their features, their concepts, and how it is being implemented. Here we try to look into C code only. So you can see data structure is nothing to do with any of the programming language. It is independent of any programming language. But definitely, since it is a concept, we have to implement using any one of the language. So since you have learned C, so here also, when we try to learn these data structure concepts, we are using C language only. So we use C language only to implement these data structure concepts. Now, how arranging this data in a specific structure is really helpful in saving a lot of time, and it becomes easier to manipulate or use them. Okay. And the same goes for the algorithm also. So always when we have n algorithms, we choose the best one depending on a given data. Okay. So which definitely the efficiency of the algorithm can be measured with respect to time, energy, and the resources. And in solving a given problem in our daily life, we choose the best approach. So that's all about your data structures is. Hello. Hello. Hello.
Hello. Hello.
Is it audible?
Yes, ma'am.
Okay. So if did you understand what we are going to study in this subject, the data structures? Did you understand what data structure is? Hello. Did you get a glimpse of what data structure is about and what we will be learning? Hello.
Yeah.
Okay. So can you give me any other data structures where you use queue? Okay, there's one data structure which is called as queue. Okay, what comes into your mind when we say queue? Okay, what comes into your mind? What is the feature of the queue? Can you tell me, one of you, can you give me a real-time example?
Ma'am, when we stand in a line, first come, first leave.
Okay, it is who comes first will be the first one to go out. Okay, it is called as first in, first out. Okay, so where do you use this application? So you use anywhere. If you go to ticket counter, movie ticket counter, or you go to a railway station, so or you go to a bus stand, you stand in a queue. So wherever you go, where you stand in a queue, so basically it's all about you use the queue data structure. So why it is more efficient is because the person who the data which is entered first will be the first one to go out. So sometimes what happens is when we arrange the data in a particular order, we want to process the data which is stored first has to be retrieved first. Okay. So in such case, we are going to use this queue concept. Okay. So can you give me any other applications of, I'm going to say, have you heard of linked list? Have you heard of linked list?
Yes, ma'am.
Yeah. What is linked list?
It's like array, but every in array we store things at consecutive locations, but in linked list we don't store at consecutive locations.
Okay, fine.
We just store some information to access next node. So
Okay.
in array
Then?
space is fixed, but in linked list we can enter as much element as possible because there is no fixed space.
Okay. So how do you differentiate when the space is fixed and the space is not fixed? What is the keyword you use in computer science?
Node.
Node. No. In linked list that every, this one is called as a node. No, what I mean to say is, with respect to memory allocation, if the size is fixed and the size does not vary, what is the term called?
Static.
Static and
Dynamic.
dynamic. Yeah, very good. Okay. So most of the applications where you know how much data you're going to deal with, we go for static. Okay. Suppose you don't know that how much data you're going to handle. So you don't know whether it could be 10 or 20, 30. So during the runtime, so you're going to change, then you go for dynamic. And that's where again your data structure comes in. Okay. So if you are dealing with non-contiguous memory locations, then you can go for linked list as well as, and again, linked list is a dynamic memory location. But whereas arrays, you can be static. Okay. So that we will see in the next class.